Hello everyone, we are presenting our IDS project in which we analyze medical cost personal datasets. My name is Himanshu Daga and my team members are Ayush Sharma, Herane Malhotra and Lakshay Jain. Now first and foremost, let's look at the dataset. Our dataset has 7 attributes, out of which 4 are numerical data types and 3 are categorical data types. Now let's look into detail in each of them. Okay, so here our code begins. First of all, we are importing all the libraries that we will be using here. Nextly, we are using data frame to store our CSV file. This is our CSV file and we have stored it in df data frame. In this we can see that our dataset consists of 1300 rows and 7 attributes. Now we will look into these attributes in details later. Now following are the plots of data distribution of each of those 7 attributes. 1 and 0 corresponds to male and female here. This 0 and 1 is a non-smoker and smoker. This corresponds to 4 different regions of USA. These are different age patterns that we have. And these corresponds to different BMI values. In our dataset, target attribute is charges. So let's do an average cost analysis. In this, we will plot all our attributes with respect to charges. So here you can see that average charges paid by male are more than that by females, and average charges paid by smokers is way too much more than that by non-smokers. Charges are nearly independent of the region. With age we can see a general trend that charges rise. It seems quite BMI independent, and it seems similarly independent of the number of children the patients have. Now let's look at pair plots of these variables to see if there are any interesting patterns. Along this line you can see that there are mirror images, that is on y-axis we have age, BMI, children and charges, and on x-axis we have again age, BMI, children and charges. So the first one here is age versus charges, where the same one here is charges versus age. Therefore we will only look into the left half triangle. Now here we can see that okay, these two are quite interesting. In this one we can see that two clusters are forming. So we will analyze BMI versus charges later, and age versus charges also, because we can see a linear pattern in this. In our dataset, we had 4 numerical variables and 3 categorical variables. But for mathematical calculations, we need some numerical values. So before moving forward, let's encode our our categorical variables into numerical values using this label encoder. Now as you can see, our sex column, children's were already numerical. Now before, sex column, smoker column and region column were categorical variables, but now you can see numerical values in them. So yes, our work is done. Now let's move forward. First thing I would like to know is correlation coefficients of these all. So let's make correlation coefficients matrix. Okay, we are interested in charges mainly, so let's look at correlation coefficients only with respect to the charges. In this matrix we can see that region, sex and children and even BMI also, but region, sex and children have no major role in determining the charges, whereas smoker and age are quite important. BMI is also a bit significant, so we will look into details in these 3 variables. This is a heat map of the same correlation coefficients. The center line corresponds to absolute ones and it is correlation of that attribute with itself. So yes, it will always be 1. Now these two red dots corresponds to BMI, and BMI is integer values, so it is also not important. Now the next thing is this one, this smoker versus charges part, which corresponds to nearly 0.7 somewhere. So we will have to look this deeply. After that, the light blue parts are important. These include BMI versus charges, BMI versus region, and age versus charges. So we will look into these also. Now we want to see that which group among smokers and non-smokers have to pay more charges. So for this we plot a bar graph of smokers versus charges and non-smokers versus charges. From the obtained figures we can infer that smoker group has to pay more sum than the non-smoker group. Let's move on to next graph. In this graph, 0 represents non-smokers and 1 represents smokers. This is count of smokers and non-smokers, and blue color represents women and pink color represents men. And in accordance with popular belief, there are more number of male smokers as compared to female smokers. Now this is a box plot for charges of women who smoke and who don't smoke, and what is the range of charges they have to pay. We can observe that higher charges paid by women who smoke as compared to those who don't smoke, and they are spread over a wider range too. Similarly, we see the box plot for charges of men who smoke and who don't smoke, and in accordance with the previous graph, again the men who smoke have to pay a higher sum than to those who don't smoke. One more interesting thing that I just saw is that the median value of smoking men and the median value of charge paid by smoking women is different. In fact, it's higher for women. So it's point to note. We will try to see later if we can infer something from this. The next attribute is age. An important thing to know about our dataset is that which age group is dominant in it. And this plot represents density of people's age. On paying attention to it, we find that lot of patients are under 20 in our dataset. So let's analyze it in detail. Now, in this age group of people less than 20, we see that there are smokers in this group also. But I wonder, does this still affect their charges at such younger age also? Let's see it. Oh, to my utter surprise, it still affects their charges. In this younger age also, they have to pay a way too big sum if they smoke, and very small one if they don't. These small tails that you can see here in non-smokers correspond to some big diseases they might be suffering with. Now let's try to analyze overall trend of charges in all age groups. In this scatter plot, non-smokers are represented by blue color and smokers are represented by red color. The following scatter plot reveals that there is a linear trend in age and charges for non-smokers, whereas those who smoke, for them we can't find any such trend. You can see these values are very much deviating from the line. Now let's look at another important feature of this dataset, which is BMI, Body Mass Index. This distribution is quite beautiful and symmetric. This curve has a similar bell shape as that of normal curve. But one more point to note here is that it is centered about 30, and BMI value 30 corresponds to obesity. So unfortunately, the majority of population has BMI around 30 in our dataset. So they are not quite healthy at least. we can say that. Now, what do you think? Does their BMI affect the charges they pay? Let's see it. Now, the following two curves are based on the people who have BMI greater than 30 and those who have BMI less than 30. From these two, there is not a lot more of effect on the charges, but yes, we can see that people having greater than 30 BMI have to pay a huge sum, whereas we don't find any value here greater than 40,000 in the people with less than 30 BMI. In our dataset, smokers attribute plays a significant role. So let's have a look at a scatter plot of BMI and charges with respect to smokers. Here, pink represents people who smoke and violet represents people who don't. Now, in people who smoke, we can see a rising linear trend with BMI and charges. That is, the people who smoke, their charges increases with the BMI, and the people who don't smoke, their charges are relatively insignificant with the BMIs, the change in BMI. Yet another feature to be explored is the number of children. Yes, this is not very significant, but still, let's see if we can find something interesting here. So, this bar graph shows the number of children these parents have. I wonder if people who have children do smoke? Let's see it then. Now, in this figure, we can see that the patients who smoke have less number of children compared to the patients who don't smoke. In fact, the difference is quite significant. So, that's all about our attributes. We can also say that smoking causes impotency, as it is quite evident from this graph, as the number of non-smoker parents are much more than the number of smoker parents. Okay, so let's conclude our analysis of different attributes in terms of charges and how they affect the charges paid by the patients. First one in the list is smoker, as it was the most correlated attribute. In general, a patient who smokes paid a lot more charges than those who don't, irrespective of other factors, as its correlation coefficient is maximum with the charges. Second attribute is age. Age is the nextly most dominating factor on the charges paid by the patient. We were able to observe a linear relationship between the age of patient who don't smoke and the charges paid by them. The next most important factor is BMI, and it has a normal-like distribution centered around BMI value 30, which tells us the majority of patients fall into obese category. People with high BMI have more charges compared to their counterparts. Last but not the least are children and sex. Sex represents to the gender, male or female, and children is the number of children. The number of children and sex of patient don't have any direct impact on the charges paid by the patient, and this was evident from their correlation coefficients as well. Patients who smoke have less number of children and males smoke more than female, and this is a generally known fact. Now, if we build a prediction model on the basis of above data, then weight should be assigned in the respective order of smoker attribute, then age, and then BMI. And we have discussed all the reasons why we should do so. Thank you and hope this analysis was helpful.